All right, so here's a nice little foldable that's going to wrap up everything that we have talked about so far. Just a reminder, we do have a test on Wednesday. So the first thing that we're going to look at is if given an equation, writing an equation from a table. Sorry, if given a table. All right, so you should open it up. Here are our steps. The very first one we are going to do is we are going to find the starting variable. The starting variable is also known as the independent variable. All right, so now we are going to, after we've found our starting variable, whatever I'm going to start with, then I'm going to decide which operation will get you to the second variable. The second variable is which variable, the independent or dependent? Very good. So you find the starting variable, which is going to be your independent. Figure out what operation gets you from the independent to the dependent. And then I'm going to write an equal sign. And then the second variable. And the second variable was which one? Independent or dependent?
Dependent.
All right, let's look at some examples over here. I have example 1. Here is my table. What two things am I comparing? Time and distance, correct? So the very first thing I do is find the starting variable, my independent. Which one is my independent? Time, all right. Decide which operation will get you to the second variable. What can I do to time to get to distance? What can I do to time to get to distance? JC.
Multiply it by 5.
Okay, we heard multiply by 5. I'm going to go through each individual one. If I take 0 and multiply it by 5, will it give me 0?
Yes.
If I take 1 and multiply it by 5, does it give me 5?
Yes.
If I take 2 and multiply it by 5, will it give me 10?
Yes.
All right. So again, what am I doing to my time? So I'm taking 5 and multiplying it by my time, and that gives me what?
The distance.
My distance. I just wrote my equation. Given my table, I wrote my equation. Pretty simple, isn't it? I love writing equations. Those are pretty simple to me. All right, let's look at example number 2. Looking at my time, my independent, looking at my dependent. Starting with my independent, which operation can get me to my second one?
14 times.
Aubrey.
Times 14.
Times 14. Does 0 times 14 get me 0?
Yes.
Does 14 times 14 get me 1?
No. You have to divide.
So will it be multiplying?
No.
No. So do you see how it worked for the first one, but when I went to the second part of my table, it didn't work, right? Sometimes it will work for your first one, but it won't work for your second one. That's why we need to keep going. Don't just stop on your first one. Keep going. Yes, I'm looking at you. So, multiplying by 14 doesn't work. So what else could we do? Vincent?
Divided by 14.
Let's see. 0 divided by 14, does it give me 0?
Yes.
14 divided by 14, does it give me 1?
Yes.
28 divided by 14, does it give me 2?
Yes.
All right, so now I'm taking my letter T and dividing it by 14, and that gets me my distance. Everybody see that? Yes? You went the other way, correct? You went from distance to time. All right, good? All right. Let's make a table from an equation. Maybe if I can open it. All right. Make a table, make a table. And again, this one right here, this one to me is pretty easy because all I'm doing is plugging in my numbers. It gives me the equation. All I have to do is plug in the values, right? All right, I'm gonna get my colored pens here. All right, so when I go and make a table from an equation, my first one is I'm gonna choose a value for my variable. Gonna choose my value. Then I'm gonna plug that value in. Plug it in, plug it in. I'm actually gonna add to this, plug in the value to equation. That way I know where I'm plugging it in, not just I'm gonna plug it in. All right, then after I have chosen my value, I've plugged in that value, then I'm going to find the value for the second variable. Whichever one that they did not give me. And then I'm going to rinse and repeat. Did y'all know that on the back of your conditioner or maybe it's shampoo? That's the directions. It says rinse and repeat. That's okay. I guess maybe I'm the only one that reads the directions on things like that. Okay, so let's look at some examples. If I go, I'm going to choose a value. I'm just going to choose any value. I always like to start with 0, just because to me working with 0 is pretty darn easy. So I'm going to choose 0 for T. Come down here and I plug it in. Let me get a sheet of paper so we can plug this in. So we can practice. Plug it in, plug it in. All right, I'm gonna move this out of the way for a second. Keeping my equation. So here I have my equation of D equals 4T plus 7. Okay, let me move it down then. D equals 4T plus 7. Does that work? Okay. So now if I plug in my T value of 0, 4, what does it mean when it's back to back like that? Times 0 plus 7. 4 times 0 is?
0.
Plus 7?
7.
4, oh sorry, that was supposed to be a 0. 0 plus 7 is?
0. 7.
7, so D is?
7.
When T is 0, D is?
7.
So I'm going to come over here, put that into my distance. See how I did that? Y'all may not have. So I came over here and stuck it right in here. When T was 0, distance was 7. So I'm just going to keep going. I'm going to plug a 1 in now. Same equation. Four times 1 plus 7. 4 times 1 is?
4.
4 plus 7 is?
11.
So when time is 1, distance is?
11.
11. All right, go ahead and find the values for 2 3, and 4. And I'll give you just a few, maybe 30 seconds or so to go ahead and fill those in. All right, so when my time was 2, what was my distance? 15, very good. When my time was 3, what was my distance?
19.
Very good. When my time was 4, what was my distance?
23.
Very good. Pretty easy, isn't it? Yeah, I like that. All right, so example number 2. My equation for example number 2 is D equals T divided by 2. I could have also written this as T divided by 2. Both of those mean the exact same thing. Again, I'm going to choose a value for my variable being used. I always like to start with 0, just because I like that. Then I plug in my values. I like to use this one, but which one do y'all want? First one or second one? First, second. I'll do it both ways. How's that? 0 divided by 2. What is 0 divided by 2?
0.
Very good. So when time is 0, distance is 0. Let's try 2 and 4. Same equation. And I'm just showing you both ways that it could be written. And then we've got T. Is that what y'all got? And then for 4, what did y'all get? 2?
Yes.
All right, so before I go on, could you use this same type of stuff if I had given you the value of, okay, so if I told you that D equals 3, how would I go ahead and find my other value? Would I use the same equation?
Yeah.
Yes, I'd use that. I'd say 3 equals T divided by 2, right? Or 3 equals T divided by 2. What am I doing to my variable? I'm dividing it by 2, right? So what is the inverse operation of dividing by 2? Multiplying by 2. Cancels out. And 2 times 3 is? 6. So I can use the same steps, plugging in my value, choosing my value, to find my dependent as well as my independent, yes? Awesome. All right, to jump over here to writing equations from graphs. Oof. Now, this is going to go through one route, and I'm going to explain to this, but if it doesn't make any sense, I'm going to tell you what even the easier route is. So you might have to make some additional notes on yours, because the way this foldable works, it doesn't quite, I don't know, it could be confusing. All right, so I'm just going to tell you what these steps are so that you can write them down, and then I'll explain them to you. All right. The first one says to draw the unit rate triangle. Then look at the x-axis for the independent. Variable. Determining how it has changed to get to the value of the y-axis or the dependent. I'll let y'all write that down and then I'll explain it to you. All right, so all of these steps would be if you were just a little bit more knowledgeable of what you were looking at. So when it says the unit rate triangle, it wants you to draw this down here like this, and there is a triangle. See how I made a triangle between these 2 points? You see this triangle? That's what the unit rate triangle is. However, I don't necessarily like this way of doing it. So the way I would suggest you, if it's giving you a table and it says, okay, write the equation, what I'm going to do is I'm going to go from the table to the graph. From the graph to a table. Because if I already know my table, I can write an equation. So I'm going to say, okay, X and Y. This would be chocolate, yummy, and cost. Look at my points that they gave me. This point here was $1. One chocolate is $3. 3 pounds, sorry, no, that's 2 pounds, was how much? $6. Now, can I keep going? Okay, what do you think 3 pounds is going to be? $9. If I follow this up all the way up to where the line is, where is it going to go? $9. Now I have me a table, yes? Remember our steps to finding the equation? What am I doing to X to get to Y? Each and every time, correct? So my equation would be 3x equals y. I like doing that a lot easier than trying to find the slope. You'll end up doing the slope a little bit later on in your mathematical career, but let's keep it simple. That's what I think. Taking your graph, putting points on it, and making those points into a table. Yes? All right. And I did identifying consistency. That's pretty easy as far as if I look at this graph right here, which one is the most consistent? This one that's a straight line or this curved?
Straight line.
Straight line. Yep. All right, glue that into your journal and continue working on your review.